On the NDT final exam, you'll have a question similar to this that asks you to calculate pixel size at a given distance. This also can relate to the smallest flaw you're able to find, and so I will extend the explanation to include that. In the case of the question that was on the quiz, I asked you to calculate the vertical pixel size for a single pixel with a camera that has a resolution of 496 by 372 and a lens that's 36 degrees by 27 degrees field of view with a working distance of 8 feet. In this case, since we're looking at vertical, that's the second number for each of the field of view measurements. So 372 pixels, our image is, or our resolution is 372 pixels tall, and it's going to be spread over a width of 27 degrees field of view. In order to do this, there's some trigonometry and calculations we need to do. So I'm going to switch over to a whiteboard and a calculator and walk you through the process. I've included the information here so it's easy to see. So again, a review, 372 pixels tall, a 27 degree vertical field of view, and a working distance of 8 feet. To help better understand this, I'm going to start by drawing a diagram. So if we have our camera lens over here, our field of view, our vertical field of view is going to extend like this. And we're trying to figure out the height of a single pixel at this end, which is 8 feet away. Using trigonometry, we have to have a right angle. So I'm going to divide this in half, and that gives us a right angle right here. So our looking at just one half at a time, the vertical height, rather than being 372 degrees, is, if we divide that in half, gives us 186 pixels. So this section, just this section here, from here to here, is 186 pixels tall. So I'm going to draw this, our triangle, a little bit bigger here. So this is 186 pixels tall. And our distance is 8 feet, and we need to find out what the height of each pixel is. So we have to find out what this height is here, and we'll call that y for height. Our angle is half of the total angle. So our total field of view, our total vertical field of view is 27 degrees. So if we divide that in half, that gives us an angle here of 13.5 degrees. So now we can do a little bit of trigonometry in order to make these calculations. And I'm going to go ahead and erase the upper one here, so I have some room to do my trigonometry. And so the first thing we got to find out is this height, our y. So y equals something. Well, using trigonometry, we can figure out that y over 8 is going to allow us to do a tangent. So using the SOHCAHTOA, as many people are familiar with, tangent equals opposite. This is our opposite over here over adjacent. So the tangent of 13.5 is going to equal the height divided by 8. And this will give us our y, this will give us our height in feet. So if we solve for this, y equals 8 times the tangent of 13.5. So if I go next door here and plug it into my calculator, we'll do the tangent of 13.5, and which gives us 0.2401, and we'll multiply that times 8, gives us a height, y equals 1.9206 feet. Now if we take that height and we divide it by the number of pixels, it'll tell us what the height is for each pixel. So if we take our y, 1.9206, and we divide it by 186, so we divide that by 186, we get a distance equals a height of 1 pixel of 0.0103 feet, or that's also equal to, if we multiply it by 12, of 0.1239 inches. So if we go back to the quiz, a single pixel should be 0.1239. Looking at the quiz, I have the answer below, and you can see here it says vertical pixel size should be 0.1239. This would work the same if you were doing horizontal. In that case, you would use 496 for your number of pixels and 36 degrees. Distance would still be 8. That doesn't change, 8 feet. The last thing we can do here, kind of an extension of that, is we can look at what's the smallest flaw that we're able to find. And a reminder is that a flaw has to be covered by 9 square pixels. And so if we're looking at a roughly circular or square flaw, that's going to be, to get a 9 square pixels, you're talking a 3 by 3 grid, something that looks like this. So how small of a flaw can we find at an 8-foot distance with our 372 pixel tall, 27 degree vertical field of view? And it's pretty simple in that all you have to do is multiply that times 3. So 0.1239 times 3 gives us 0.372 inches. So the smallest flaw we would reasonably be able to find would be 0.372 inches square, vertical and horizontal.